Okay, 2 points inclined at 55 degrees to the horizontal. That's 55 degrees. We've got A and B. We've got A down here and B up here. That's 4 meters there. Particle mass 2.5 kilograms. Particle there. I need to. It's going to get messy. I can see it's going to get messy already here. So what I'm going to do is I'm actually going to redraw this thing. I'm going to get rid of this diagram and I redraw my diagram. So my 55 degrees is how I normally draw something, and I should be able to get more space. So I'm going to label that as 55 degrees. We'll see if I actually get more space like this. That's A, and that's B. And we've worked out that that's going to be worked out, told that that's 4 meters. Particle of mass 2.5 kilograms. So therefore I've got 2.5 G coming down here. And I've got normal contact force going up. Don't know if I need it. I've got resistance to motion. That'll be my friction. Because it says that mu is 0.15. And as soon as I see mu is 0.15, then I know that I'm going to have some friction in there. And projected out the plane. Okay, and the speed at B is 6.7. So speed here is 6.7 meters per second. I think that's pretty much everything I've got on there. So first off, I'll put this angle in here, A. This is always the angle of the slope, so that's 55 degrees. I know it doesn't look like it, but it's a small angle. It's much bigger, so you can tell which one it is. Just have to be careful in case I have to sort of picture what's going on. I may have to come back to my picture here. But we'll see what we've got. Well, it's moving, so as soon as it's moving, then I know that I'm going to have F lim equals mu r. And it's to do with the work done against a frictional force. So I've got to work out what F is. I'm told what mu is. I need to know what r is. If I need to know what r is, I need to resolve perpendicular to the slope. And I would say that way must equal that way because there's no acceleration in that direction. So that means that r equals, split this force up, it's this bit here, which is the important bit. That will be the cos bit. The other one will be sine. So this one will be 2.5 g cos 55. So we now know what that is, so we can now put this into there. We get F lim equals mu 0.15 times by 2.5 g cos 55, and that equals 2.107893,404. And now I can, having worked out what the friction is, I can work out what the work done against friction. So work done against friction. Now I like always putting down formula, work done Fs. So it's the force times by the distance. And in this case here, the force actually is friction, so it's actually F. But so that equals towards that number, 2.1 whatever, times by the distance is 4, and that will give me 8.431573,614, and it's a force times a distance, so it'll be newtons meters for the work done. And that's the first part. And then for the second part, I've got to work out the initial speed of P at A. And in M1 we generally use Stuva, find the acceleration by resolving. We actually don't know this. It's necessarily got constant acceleration we do in this situation, but in M2 generally go for energy. So let's do energy. And what we do know with energy is we've got the total initial energy equals the total final energy. Well, we would do if there's nothing taken out of the system or put into the system, and friction will take it out of the system. And so what that means is our total final energy must be less than it would otherwise be. So what I'm going to do is I'm going to put down plus work done against friction on the right hand side, because that means that the initial energy will turn into the total final energy and the work done against friction. Okay? And total energy, we've always going to have potential energy plus kinetic energy, and potential energy plus kinetic energy. Obviously, if you want to put gravitational potential energy, please do. And I always like putting the formula down. mgh, just to make sure I don't forget any part of that. And kinetic energy is half mv squared. I'm only going to write down once, and I know it probably should be U for the initial energy, but I just write it down like that. So gravitational potential energy, we're going to take the start to be 0. That's our basic height here. And then we've got plus a half times by m, which is 2.5, times by v squared. That's what I want to find. And that equals our final bit. Well, our final bit will be gravitational potential energy will be m, which is 2.5, times by g, times by this bit here. And we've got, if I draw a line across there, that's 55. That's obviously 55 as well. And so this will be 4 sine 55. So 4 sine 55. And then plus half mv squared, half times by m, 2.5, times by v squared, which is 6.7 squared. And then plus the work done against friction, which I just worked out, 8.43, etc. Okay. And that gives me 1.25 v squared equals 144.820974. Divide by 1.25 and then square root it, and that gives me v equals 10.763687 in meters per second. And that's the question done.